could just watch pretty pictures together.
Yeah, once you do that once, and that's what they want every time. It was on the academic challenge. It was in a question. Mandelbrot was a question or an answer.
It wasn't on Jeopardy, so it doesn't matter.
But I don't think we have any academic challenge in here, do we? All right. What can I multiply in? Kelsey, what do you think? Okay, he says the 3x4 and the 4x3. He's going to get rid of the F's. I'm going to make one minor adjustment. If you multiply this one by 4, to get them to add up to 0, one of them has to be negative. So make it a -3. Now, I'm sure some of you looked and said, I'm going to multiply the top one by 5 and the bottom one by 6. That'll work as well. So if you started down that path, that's fine. I'm going to use Ian's path here. I might need a little bit of help. 24D plus 12F equals, what is that going to be? 64, and then 65, 28? 88. 65, 88. 65, 88. And then negative 15D minus 12F equals, don't give me a chance here. 3, 15, 45, 46, 50, 46, 53. Is that right?
Yeah.
46, 53. Negative. And now you get 9D equals, and then that's going to be 5, 35, 9, 1935. Okay, now divide by 9. Divide by 9, and we get D equals 2, and then 215. So double stack. Each double stack is 215, according to this. Now, how do we find out how much is frosting? Plug it back in. Take one of your two original equations. So I'm going to take the first one, 6D plus 3F equals 1647. D is 215. Equals 1647. And then that is 1290, I'm hoping. Plus 3F equals 1647 minus 1290 minus 1290. 7. I'll go. 357 equals 3F. Divide by 3. And each frosty is $1.19. Okay. You will have to do 2x2 systems today. Okay, so this is what we call it. You create 2 equations and 2 unknowns, and then one way to solve them is elimination. Another way is substitution by getting one of the variables by itself and substituting the other equation for that one. But we are going, kind of agenda is where we're heading. We only do one section out of chapter 8, section 8.2, then we jump into chapter 9. And then that'll be kind of like this section of chapter 9 will be our last big test. And it'll probably be in a couple weeks for that. And then after that, do we have any seniors in here? You guys got one lonely senior in here. Okay, you'll take you're almost done. Because you'll take your exam, what is that, May 13th?
I don't know.
May 13th or 14th, right around there. Wait for that. And then we'll kind of clean some things up, and then we'll get ready for our final exam. But we do have just one final big test. We will quiz over this, and it's, again, with this late start stuff, it makes things difficult. We're going to quiz on Monday, but I believe it's going to be either a partner test or a partner quiz or a group quiz. I'm not sure how many people we'll put in there, but give you at least 2 people. We'll see from there. All right, now that was a 2x2. We're going to do 3x3. I'll give you your guided notes here in a second. What do you think the graph x plus y plus z equals 4 looks like? So let me maybe back it up a second. Do you know what x plus y equals 4 looks like? If I rearrange it and I write it as y equals negative x plus 4, does that help? What's that look like? Is it a parabola? Please say no. Oh,
No.
it's a line. It's a straight line. Yes, with a slope of -1 and a y-intercept of 4.
So I don't know about that.
So there. But now, what does this look like? We throw a z in here. This is a three-dimensional graph. You got your x-axis, you got your y-axis. Z is the vertical axis. So let's take a look at what that graph would look like.
Is it video time?
Not video time.
Dang.
This is a guess nice.
So, everybody should have a 3D calculator handy. If it'll load. Okay, so there's our grid. Okay, you can rotate it, twist it around, all kind of good things. I'll leave it right there. Let me put in x plus y plus z equals 4. Okay. And you can twist this around a little bit here. And can you tell what that is?
A plane.
It's a plane. It's like a sheet of paper. So we're going to deal with 3 of them. And so if I have a 3x3 system, how many planes are there? 3 of them. We want to see how they intersect. Okay, so it gets a little more complicated than the 2x2 system. 2x2 is just 2 lines. This is 3 planes. All right, all I'm asking you for this one here is that point a solution to all 3 equations. Just kind of do that mentally, use your calculator, whatever. I'm going to pass out you guys notes while you're doing that. But that's all you're checking is that point a solution. Oh, you're welcome. Yes. So Sierra, is it a solution or not?
Yes.
Yes, it is. It works for all 3. Okay. There might be more solutions, but we know that one is at least a solution. Yep. And maybe. Oh, there we go. That was easy. All right, so if you do check it, you do plug it in. It works for each of them. 5 times 2 is 10. 3 times -1 is -3. -2 times 3 is -6. 7 minus 6 is 1. So that one works. 2 minus -1 becomes +1. +3 equals 6. So that one works. 2 times 2 is 4. 2 times -1 is -2. Minus 3 gives me -1. Okay, so it is a solution. So that's all you had to check. Now, we said with 3x3s, each one of them is a plane. So what happens a little bit different than with 2x2s? You could get 3 planes that intersect in a single point. Just one solution is the answer. You could get 3 points that intersect in a line. You've got infinite solutions. You could have 3 planes that are all the same. That's another set of infinite solutions. You could have 3 parallel planes. No solution. You could have two parallel planes, one plane intersects, it's still no solution. And then the last one is you have three intersecting planes, they intersect in some way, but they don't all three intersect at the same point. So we got more options for no solutions. We got more options for infinite solutions. Okay, and really it looks like one solution is the one that occurs the least often, but that's the one we're going to concentrate on today. To solve this, I'm going to go over a couple ways to solve these. You can interchange any two equations. You can flip the order. You can multiply any equation by anything other than zero, any non-zero constant. And then you can add a non-zero multiple of one equation to the other. Essentially what we just did with the 2 by 2, you can multiply them by a constant, and then you can add them together. Those are all going to give you equivalent statements. And that's how we're going to solve a 3 by 3. And let's start with that first one. Now, what do you got to watch? If you make a little mistake early on, then the rest of it is going to be off. Now, I got 25 people double proof in everything I do. Somebody usually tells me if I made a mistake. You don't. So you really got to double check each step, because if you make one little mistake with a negative or you add wrong, then things kind of build up. All right, we got three equations I need to figure out. And I'll tell you, because if you happen to be working ahead, all your answers should be whole numbers today. Okay, just so if you get a fraction, that's going to be incorrect. First one I'm going to do is by substitution. I'm going to pick one of the letters to get by itself and substitute in the other equation. So we got X, Y, or Z. Popio, which one do you want to get by itself?
The Z.
He says the Z. So I'm going to take the first equation. I'm going to say Z equals 6 minus X minus Y. This one is nice because it's easy to get either X, Y, or Z by itself. We're not going to deal with messy fractions. Take this, and you need to plug it into Z for both equations. Okay, for both equations. And so I'm going to have, for the first one, 2x plus 3y minus, now since it's a minus Z, put whatever you plug in there in parentheses, because you're going to have to distribute that negative sign. And then beside that, I'm going to do the second one. Okay, I'm going to do them side by side. I got 3x minus 2y plus 3 times 6 minus x minus y equals 8. Distribute, combine like terms, and take any constants and put them on the right. So I'm going to do that here. So I get 2x plus 3y minus 6 plus x plus y equals 11. 2x plus x is 3x. 3y plus y is plus 4y. And if I move the 6 over, I get 17. Do the same thing on the other side. So I get 3x minus 2y plus 18 minus 3x minus 3y equals 8. Actually, something nice happens here. Because what's 3x minus 3x? 0. So that works out good. I get negative 2y minus 3y, which is negative 5y. And then if I subtract 18, I get negative 10. Okay, that's a good thing, because I can figure out what y is right now. Divide by negative 5, you get y equals 2. Our whole goal is to figure out what all three variables are. So now I can plug in y equals 2 over here and figure out what x is. And so I get 3x plus 4 times 2 equals 17. That's 8. Subtract 8, I get 3x equals 9. X equals 3. And then I'm going to use the, when Nathan said to get z by itself, what do we have? Z equals 6 minus x minus y. And then that gives me z equals 6 minus 3 minus 2. Z equals 1. Okay. All right, since this happened, this is the case where all three intersect at one point. Like there is not infinite solution. That is the only solution that works for all three of them. We'll go over the other cases where that happens later, but today is just one solution. It never hurts to double check, because if you made a mistake in here, you could still get nice numbers and think you have the right answer. But you go back, it doesn't hurt to double check them into the other equations. So if you plug in 3, 2, and 1, what does that give me? 9 minus 4 is 5 plus 3 is 8. 2 times 3 is 6. 6 plus 6 is 12 minus 1 is 11. So you absolutely know you're right. All right, so that one worked out a little bit nicer, and that was substitution. All right, flip it over there on the back, and I'm going to kind of label these equation 1, 2, and 3 a little bit easier to work with. I'm going to do an elimination on this one. You need to pick two sets of equations and eliminate the same variable. Sometimes the variable you eliminate is easier than others. Like you got to look, see, is it easier to eliminate the x? Is it easier to eliminate the y? Or is it easier to eliminate the z? Some cases it doesn't matter. Dominic, what do you want to eliminate? All right, he says y. Out of which two equations first?
1 and 2.
Okay, now he picked the ones because they are lined up. They will automatically add up to 0 right away. So let's eliminate the y. I'm going to take equation 1, which is 2x plus y minus 3z equals 7. X minus y minus 2z equals 4. And I get 3x. That does add up to 0. Minus 5z equals 11. All right, it doesn't give us like an actual answer this time. Every now and then it will. But it at least whittles it down to one less variable. All right, now here's what you got to do at this point. You got to pick two separate or another set. You can either pick equation 1 and 3, or you can pick equation 2 and 3. But you have to eliminate y again. Okay, so limit 1 and 3 or 2 and 3 for that one. Caden, which one do you want? You want 1 and 3 or 2 and 3?
Let's do 2 and 3.
2 and 3. Okay, I actually like that because one of the y's is negative, one's a positive. So for 2 and 3, I get x minus y minus 2z equals 4, and then I got 3x plus 3y plus 2z equals 4. All right, one thing you got to watch. Some people will say, well, hey, I can get rid of the z's. I'm just going to do that. Well, if you do that, you're going to have an x and a y here, and you're going to have an x and a z here, and you're going to get stuck. Doesn't help you. Regardless of the situation, you've got to eliminate the same variable. All right, do you know how you would eliminate that? What do we have to multiply by? Tessa, what do you think?
3.
Which equation? Yep. Yeah, that top equation, we'll multiply that one by 3. And when I multiply, I usually work left to right. So it gives me 3x minus 3y minus 6z equals 12. 3x plus 3y plus 2z equals 4. And so I get 6x minus 4z equals 16. Didn't work out as nice as the other ones, but here's our goal. Is in some way we got to take it from a 3 by 3 down to a 2 by 2. And they got to have the same two variables. So now I got 3x minus 5z equals 11. I got 6x minus 4z equals 16. And now we're going back to the frosties and the double stacks. All right, take a look. What are you gonna multiply by to solve that one? Okay, like I said, you can have you can do it different ways. Connor, we'll let you tell us.
-2 on the top.
-2 on the top, because that's gonna give me a -6x. -6x plus 10z equals -22. I get 6x minus 4z equals 16. I don't need to multiply the bottom one by anything. And then I get 6z equals -6. Looks like z equals -1. All right, go backwards now. We keep working back up through. Plug in z is -1 into one of those two equations and find x. And I'm going to take the, and it doesn't matter, but I'm going to take 6x minus 4z equals 16. I know z is -1. 6x minus 4 times -1. Looks like I get 6x equals 12. X equals 2. And now go back up. I'm going to pick that equation 2. I got x minus y minus 2z equals 4. And then I got x is 2, z is -1. I get 2 minus y plus 2 equals 4. -y plus 4 equals 4. All right, be careful here. I get -y equals, that's a 0. It's an ugly 0. And so y equals 0. That's fine. My ordered triple, it's called an ordered triple, is 2, 0, -1. That's the only answer that works for all three. You can go back and test it just to make sure. But 2, 0, and -1. All right, look at that third one. Sometimes this one causes more problems than the others. Even though it should be quicker. Each equation only has 2 variables, but in total you have 3 different ones. You have an x, you have a y, and you have a z. So you still could call it a 3 by 3. So nobody ever does this, but you could say x plus y plus 0z equals 9. You could say 0x plus 2y plus 3z equals 7, but you don't necessarily need to do that. All right, so you can come up with a strategy. Think about it, where you're heading. I'll go through it here in a second, and I tell you what, probably about 5 different people did it. They come up with 5 different ways and they could all work. So it's not one where there's a certain specific way that works. Some are quicker than others. Some do lead to dead ends and don't work at all. But think it through. If you think you're confident, you want to keep going, that's fine. But make sure you get a whole number for your answer.
What do you got?
Elizabeth, what do you got?
A little bit. It's a little, it's a little
Just keep that next one as 2 Z.
So there, that's it. That makes sense. That's next sense.
All right, now here's the hard thing is people could have gone different ways and they all can be correct in some way. So just, the idea is to get a 2 by 2 system somehow. And so we got 3 different variables running around. And let's kind of see where we're going with this one. Audrey, what'd you do first?
I changed the first one to y equals 9 minus x,
And
and I substituted that into the second equation.
Okay, that'll work. All right, so we're going with it. We're going with it. She says this is y equals 9 minus x. And she substituted into number equation 2, so that becomes 2 times 9 minus x plus 3z equals 7. So I get 18 minus 2x plus 3z equals 7. Negative 2x plus 3z equals negative 11. Now again, watch your steps. I got everybody here helping me out, and sometimes you don't have anybody. You're stuck though. You don't get an extra y, but here's the whole point. As long as you can find another equation with x and a z in it, you can use that equation with our new equation, and you get a 2 by 2 system. So normally, whatever you did, if you did elimination, if you did substitution, after that first step, you should have an equation that will match up in terms of the letters with one of those 3 from up above. And then you do a 2 by 2. And so I got x minus 2z equals 4, and I got negative 2x plus 3z equals negative 11. I'm going to assume that you multiply everything by 2 on the top. And I get 2x minus 4z equals 8. Negative 2x plus 3z equals negative 11. And I get negative z equals negative 3. And if I did everything right, I get z equals 3. You agree? All right. Finish up wherever you're at. Keep going. If you're stuck, let me know. Get all whole numbers. Okay, so like you said, yours might not look the same as this, which is absolutely fine. Get it? Okay, so 2 times 7, 10 minus 6. Of course it's so, yeah. Okay. Good. All right. Good. All right. That's good. Right. Okay. Come on. That's the guy. Yep. Okay. And Tyson, good?
I'm good. Let's see.
Good run around now? Okay. Right, better off just plugging. You click it back to here, yeah, plug it back in one of the 3. Right there, and that's gonna guarantee will be the end. Okay. All right, got z equals 3. These 2 they created here, I'm gonna have x minus 2z equals 4. I get x equals 10. And now you don't have an equation with all 3. I just need to find what? Y? So I can either use equation 1 or equation 2, doesn't matter. It says x plus y equals 9. Whoops. X, hey, put that. X plus y equals 9, and we know x is 10. So y equals -1. So I get the order triple 10. Bless you. -1, 3. Okay, 3. All right, we're not going to get through the last one, but I want to get it set up. Okay. Find the quadratic function whose graph contains the 3 points. At this point, you're like, what does this have to do with what we've been doing? We're going to create a 3x3 system that'll solve this. Now, in general, a quadratic function is y equals ax squared plus bx plus c, right? Ax squared plus bx plus c. What we don't know the a, we don't know the b, we don't know the c. Okay, that's what we want to find. But I have to have 3 points. And now let me do the first one here for you. For the first point, x is -2, the y is 51. So take your general form, plug in 51 for y. A, we don't know, but x is -2 squared plus b times -2 plus c. And that's going to simplify to 4a minus 2b plus c. And this is a equation. It just doesn't have x, y, and z. It has a b, and c. All right, find your other two equations using 1 -9 and using 5 -33. And so I get -9 equals a times 1 squared plus b times 1 plus c, which becomes -9 equals a plus b plus c. Okay, so not very exciting, but that's fine. And then I get -33 equals a times 5 squared plus b times 5 plus c. And I get -33 equals 25a plus 5b plus c. All right, so that's where we're at. Now I'm just going to put the constant on the other side. You got 4a minus 2b plus c equals 51. We got a plus b plus c equals -9. And I got 25a plus 5b plus c equals -33. Whoops. Okay, so there you go. Those, and now no different than what we just had. Once you find your A, B, and C, you're gonna have your equation. But we'll finish that one tomorrow. Okay, just 3 problems. All your answers are whole numbers. If you get a fraction right off the bat, hey, check that you wrote the problem down correctly. That is probably the biggest mistake. And then just watch your math within each problem.
The paper I was using before spilled a bunch of water on the paper, so now most of my notes and most of my papers are debatable. I mean, I'll probably tear it if I use. I was trying to get some out for you, you know?
When are you gonna run next, Clem?
I don't know, I ran yesterday and I'm in a lot of pain, so.